So even though you are under stress, the show must go on, and because you have a diverse biology in your soil, it is carrying. Some of them are dead, but many of them are alive, and they are carrying on the process. So that's why functional redundancy is important. So yes, 10 of them are doing the same thing. Why should I care? It's redundant. But in nature, you see redundancy. That's where you see it. And redundancy is good in this case because environmental stress is sudden, unpredictable, and in a very high pressure growing system that we see with rising prices with the farmers, they need to rely on this redundancy. So that's not limited on only one or two species that you put. You are reliant on thousands of species. If some of them are dead, that's fine. The process will go on with the remaining one that are alive.
This is an episode you do not want to miss. Let's get started. Welcome to Soil Talks Podcast, where today we have the guys from Purple Cow Organics on. We have Jared Reuter, Kyle Dahlfeld, as well as Keyshawn Mahmood. All of them have very, very special talents that they all bring to Purple Cow Organics, and they're about one thing. They're about biological diversity in soil. And so we're going to jump right in. Biggest thing I can say here is all farmers know, or the majority of producers know, growers find a plateau at some point. That NPK levels are perfect, but yields plateau. Disease increases. Why? Because the engine of that soil, the biological engine, is missing. And that's where Purple Cow Organics and the products that they bring to the market really help fix that issue for farmers of all sizes as well as gardeners. Guys, welcome. We appreciate you guys being here with us today.
Thanks for having us.
Thank you so much.
Yeah.
Absolutely. So like I said, how we kind of introduced this, that's the problem that a lot of, producers, farmers, greenhouses, you name it, anybody that grows anything, that's what they run into, right? They run into issues. Their yields usually plateau. They have disease increases. They have issues, right? And all they're really focused on 9 times out of 10 is NPK, the old conventional systems of growing plants, right? Feeding hamburgers to soil. That's the easiest way I like to say it, right? Just nothing special. It's hamburgers and French fries to soil and not really looking at the life of the soil itself. So basically, at the end of the day, what Purple Cow Organics did is they brought this diverse biological inoculant to market, right? And it's not just about having microbes. It's about having a community of them. And I think as we get into this, we're going to help you guys understand exactly why it's so important to not only have a thriving, living ecosystem in the soil, but also what it does for plant health, fertilizer reduction, all of those different things, and resilience really over time. So I'm going to hop in, and this one's for you, Jared. Why did Purple Cow, I guess, move away from standard composting to advanced biological extracts? Discuss the shift from waste management to rhizosphere engineering. And I know you guys still do composting, but why are you guys starting to see, or why are you guys starting to move away or create a new product?
Yeah, so it's actually been quite the long journey. Like I said, I've been here since '08 when we were founded, and we are still the largest compost manufacturer in the state of Wisconsin. Besides just the bioactive large agriculture, we also deal a lot with retail, smaller organic farms, and professional greenhouses and grower products. What we were finding when we originally were trying to sell compost to large farms is it's just not realistic for them to apply that to a field, right? So you got a farm that's 10,000 acres. You only can get, let's say, 35 yards of compost on a truck. How are you going to manage that, right? All of a sudden it rains in the spring. Okay, well, now we got all this logistics lined up and we can't get it on the field. So, we really started thinking, okay, well, we really want to get the biology down. There's other micronutrient packages they can put down. There's other carbon sources, but how do we get that biology? And we didn't want to take a simplistic approach that you see where a lot of companies might have 1 or 2 strands, because we truly believe broad diversity is what, makes it a successful product. And, that's really the transition. It wasn't immediate. It took many years for Liquilife to catch on, and it was having to prove results on farm trials, letting a farmer use it so they can see for themselves. So it's been a transition, and we still do sell a lot of compost, but again, those are primarily the smaller, less than 100-acre organic farms than all those other markets we talked about.
Yeah, no, and that's, I understand that completely, just due to the fact of the logistics of hauling compost, right? I see guys
and
spreading it. That's exactly right. It takes a lot of diesel fuel to not only get it to the farm, but to get it spread out on the farm. And sometimes in some instances, you do have to have it to build soil structure, to do certain things. But when you start getting into massive amounts of acreage, that's the one thing that we've always kind of, I don't want to say talked against, but say, hey, like you really have to look at the logistics of this. And so that's kind of where then the BioActive Liquilife came in. It's creating that broad spectrum microbial inoculant in order to be able to put across an entire field.
Yeah. And kind of where it, one of the other things too is, if you hear the back and forth right now with Purple Cow Organics and BioActive, is when we originally founded, we were really heavy into organics, right? And what we were finding over time is basically the regenerative farms, no-till farms, and conventional farms are getting an even higher ROI than organic farms because they have different practices.
Sure.
And, it was difficult to talk to all the different audiences. So we basically made a sub-brand BioActive to really start promoting and say, this isn't just for the organic guys. This is for changing growing systems for all farms.
Absolutely. And I think both you guys, Kyle, Keyshawn, you guys both, I'm sure, will agree with this as well. But really, the guys that need a lot of the help are the conventional guys. Those are the guys that are kind of struggling at this point, right? That are kind of almost in this, debt loop that they can never get out of, right? Like it's really tough for them to ever move away from that. And so by adding that, that's kind of that's great that you guys are focused now on conventional. Obviously, you can service organic, which is important as well, but they already kind of understand it. They're focused on soil health. They're building that soil. Whereas these conventional guys, you guys are stepping on and saying, hey, we can do this. And that's, I'm sure, where the research is coming in with Keyshawn, is showing these conventional guys that they can do it. And then Kyle, your expertise being brought in to be like, all right, we can do this on 10,000 acres. It's not a big deal. This is how we're going to do it.
Yeah.
Is that kind of what we're looking at?
For sure. When you look at organic farms, a lot of their inputs are plant available. And then when you look at a lot of conventional farms that are mineral based or have a high salt index. So adding that biological community to that soil profile really makes that much more available. So we're seeing a lot of pop.
Absolutely. Yeah. And so now, I always like to look at biodiversity and building resilient systems as kind of an insurance policy, right? So is there any way, Jared, you can kind of explain to us how the diversity creates resilience? If one microbe species thrives in heat and another in cold, a diverse soil is insured against weather swings, correct? I mean, that's an easy way kind of to wrap your head around it. But can you kind of explain to us, why it's important to have that broad spectrum?
Yeah. And, that is one of the complexities of our product, is that it is very diverse, and there's other diverse products out there. And it really allows anybody can sell one or two, let's say, bacillus strains, but how are they going to make sure that when that hits the soil, that's actually what the soil needs? And if you provide it everything and build a whole ecosystem, that ecosystem then can build the way it needs to for that crop, that soil type. I mean, there's lots of different soils, lots of different moisture contents, a lot of different weather patterns. So if you only have one or two, there's no possible way that you can think that that's going to work every single time. We do see, one of our challenges is, to try, we're proving out, trying to explain to a farm, let's say they get a 60 to 80% ROI the first year, right? Well, that second year, that's probably going to be harder to achieve. And then explaining that really what you're doing is building a long-term, but eventually you're going to kind of keep making the same per acre, right? Now, then it's easy to look at and say, well, what happens if I cut it out, right? Well, then you might start taking those steps back. And we do, typically encourage multiple touch points with biology because that helps. The soil also needs different things at different times.
Sure.
But really, we're basically about trying to get the soil back to where it should be and give it all the biology that should naturally be there and letting that ecosystem go to work for you.
Absolutely. Because, and I think you can also maybe probably talk a little bit about this, Keyshawn, but the fungal to bacterial ratios, things like that. Not every crop is exactly the same. Some crops require more fungal to bacterial, vice versa. Yeah, I'm sure.
Yes. So I will add to what Jared's comment that yes, when we are going with a broad spectrum ecosystem and providing that into the soil, while it is meeting the requirement for the plant nutrient requirement and also making minerals soluble in the soil, because it's a broad spectrum and it is diverse and abundant, it is giving the soil and as well as the ecosystem two very important attributes. Number one, resistance to any change, right? Because it is mimicking and it is in the natural environment. It is resistant to sudden change. If that, let's say, it has gone through a little bit of change, but because it is a diverse mix with a diverse population with abundant microbial communities, it is resilient to come back, spring back after that stress has passed. And talking to your fungal and bacterial ratio, yes, certainly the soil dynamics, soil pH particularly, and how much organic matter you have in the soil dictates whether it's a bacteria and or fungal heavy soil. So fungi typically tend to be more nonchalant to pH changes compared to bacteria. Bacteria, because they're tiny, their cell walls are not developed as fungi, and they don't have, obviously, don't hyphae, they don't spread much, but they're big in numbers. So what they do, so they propagate very fast. However, anytime you have from acidic to going to alkaline pH, they are going to have changes, and they do better close to neutral to slightly acidic to slightly alkaline pH. While you make the adjustment in your soil pH with organic matter input or any other inputs, any farmer, he or she does, he is actually engineering his own rhizosphere, right?
Yes.
And sometime
Absolutely.
when this balance gets out of whack, he can bring in biology, he can bring in carbon. And it's just like someone playing with a Play-Doh and making a castle. All right, I need one more fort here, I need a cannon there. So it's a lot with biology and carbon. You can engineer your system and meet your soil and plant requirement.
Sure. And it'll kind of adjust, right? I mean, it's going to adjust kind of if those fungal spores will be laying in that soil, right?
Yes.
Or whatever that looks like. And when that plant's calling for something in the rhizosphere, in that root section, it's going to say, hey, I need more fungal biomass right now, or whatever that looks like. And it kind of, it'll adjust itself per se. I mean, obviously the life has to be there, but then it will start to kind of change, right, to what those plants are requiring.
Yes, most definitely. Depending on, so plants would excrete through its roots sugars, exudates, and that is a call for its surrounding environment. Hey, I have this food. Why don't you come and join me? It's like a calling for a buffet, and they're all eating. So depending on what growth stage your plants are, they will secrete different kinds of root exudates through in the root zone. It's a very narrow area, but it's super dynamic because all sorts of sugars, root exudates, enzyme the plants release. And depending on what food, what bacteria and microbes and fungi like, they're going to come and populate.
Yes.
That's the dance that they play that we don't see, but we can kind of sense through how much fruit you have, looking at different parameters in soil, organic matter, enzymes. So yes, you have to have the life in there that you already mentioned. You have to have the balanced life so that where the plant is asking for at different times of growth stage, you have those microbes there who can attend to the plant's need.
Which then equals resilience, right?
Yes.
So as you go through these issues, kind of what we were talking about, and that's the insurance policy per se for your fields and your crops. Well, that's perfect. Now, I guess it's like, breaking that monoculture mindset, transitioning from treating soil as a sterile cup, right? Because there's a lot of farmers, like you look at strawberry growers, you look at a lot of different growers out there, right? And I mean, they'll even get to the point of where they're basically nuking the soil in some senses. When I say nuking the soil, it's heavy amounts of fungicide, things like that to try to sterilize the soil, even putting soil sterilants out, right, before their next crops come in. So how is it that we're transitioning from treating that soil, I guess, as a sterile cup that holds fertilizer to a living gut that digests it? And that's kind of for Jared. You see, I mean, it's how are we doing that,
Well, I think a big part of it too is how the agriculture environment is also changing over time, right? And people learning more and more, but also understanding that, as margins get tighter, we need to find new solutions. And as fertilizer prices go up, we need to find new solutions. And a lot of farms, they might have been able to be able to put down X amount of fertilizer at 1 year, but then over the last 10 years, they keep having to apply more and more. And why is that? And most of the time it's because the soil biology is not where it was 10 years ago. And as you lose a lot of that, you're basically taking a key tool that you had or could have and not having it. And soil biology is critical to solubilize nutrients, reduce disease, and a lot of other factors. And it's amazing when we've done DNA testing. I know you're very familiar with this too, Brandon, that when you start looking up a lot of these species, it's crazy, the different known benefits that they have to the soil.
Sure.
And I do think a lot of it, though, is also driven where farms are trying to find new solutions so they can continue to farm, and some of them have been around generations. And why are things getting more difficult?
Yeah, no, absolutely. And I agree 100% with you. And it's funny when you talk about soil DNA and things like that. And it is just a snapshot of the ecology, right? Things can change quickly. But when you get that snapshot and you look at it, it is pretty amazing what's there. And that's the part of the system. It's hard for, I think, a producer or anybody that's growing anything to wrap their head around the unseen giants, right? That's what I like to call them, the unseen giants, the guys that you don't really see, the bacteria, the fungi, those things. Like, it's hard to wrap your head around that. But that's exactly right. They've treated their soil for so long. It's like you said, a sterile cup. It's NPK. We're putting it in and we get out this, right? The cup dumps over, the crop grows, and you get the crop. But it's coming to this point in time with like what you guys are doing where these farms are looking for other answers. They're like, okay, wait, I've been down this route. Everything's plateaued. My crops are getting eaten up. I can't, it's just continuously buying inputs, putting inputs in to try to get a crop out. And sometimes crop failure happens a lot more often now, and issues with crops and things like that. And now they are looking for that solution. Let's treat that soil now as a gut, right? That cup is a gut that we need to, whatever we're putting in needs to be basically cycled out.
And it's really difficult to try to sell that, right? You can't see it. And as you know, we work with landscapers too, right? Why, when a landscaper puts down fertilizer, why is the fertilizer a bright color? Well, so somebody knows that you were actually there, right?
Yeah.
That's
right.
That's basically the reason. So they can see it. And when you can't see something, how are you going to know it's going to work for you? And that's why a lot of farms, dealers, distributors, whoever we work with, they need to see it first. The good news about having something that's broad spectrum and that is going to work in most conditions is, 99% of the time they're going to see a result and start believing it. But then that's how they see it, right? They see it when they get the results from their field. Hey, we were able to cut down fertilizer 20% and still get bigger yields. And the one thing that we changed is adding a broad spectrum biological to that mix.
Yeah, no. And I think that's important. It's kind of what Kyle said too. The organic guys have all of those bioavailable nutrition sitting in their soil, whereas these other guys don't. Right. So by doing that, we're going to put this biology in, which will cycle that nutrition. We can cut down on that. It's fixing it into the soil profile. It's being utilized more efficiently. Those types of things are happening. So yeah, no, I have to agree with you. And it is hard to say, or hard to sell. And not only so much hard to sell, but I think that's why people need to be educated on what is a good biological? What are you looking for in the marketplace? Because I'll tell you what, at this point in time, there's a lot of companies jumping into it and saying, hey, I have the next best thing. Oh, I have the best thing. And it's marketing and it's smoke and screens and
a lot of them are big,
all those things.
Big companies, Purple Car Organics, is 25 people, right? We're not, one of the large agrochemical companies. And those are the ones now they're trying to penetrate that market. Most of the time they're limited species. They have large budgets. They work with very large dealers. So, then what happens is, let's say they come out with a limited species that's just 2 strains, 3 strains of bacteria. The farm didn't see the results that they wanted. Well, now Kashan has to go in there and try to say, well, you should try a biological. Well, I did that before and it didn't work. And then going into the educational process of explaining, what did you use? How is this different? And getting them to try it again. And it's a long process. But again, the best thing is having a product that works, because if you have a product that works, go give it a try, right? And that's kind of part of the sales process is like, we'll stand behind it. We think you're going to have success when you use it. Go give it a try. And then, we'll talk again next year.
And give us your worst acreage, right? Like that's my thing. Like, give us the stuff that's just where you're not making money at this point, and you'll see very quickly the difference. So, well, no, that's great. I think that's perfect. Keyshawn, this one's kind of more for you. We're going to talk about some functional redundancy.
Excellent.
This is kind of the meat of biological science, I think. And I think this will be something good that you'll be able to really put a lot into. So if you could, Keyshawn, could you explain why, say, 1,000 species or more are needed if the environment changes, that functional redundancy? And we kind of talked about it a little bit just a second ago. How does that ensure that plant still gets fed?
Excellent. Thank you for the question. With 1,000 plus more species. What essentially you're talking about mimicking the nature. So in nature, in soil, in native soil, we're not looking at even 1,000. We are looking at millions of different species from different taxons. So what it brings is when all these microorganisms are in equilibrium with each other in that environment, they are interacting with each other. And while they're interacting, they're creating byproducts. Just like us, we are respiring, exhaling, oxygen giving, CO2 respiring, and we're sweating when we're running, right? So microbes, when they interact, they create organic acids like malic acid, citric acid, gluconic acid. They create enzymes, they create different kinds of available nutrients. And these byproducts, yes, they are good for the plant roots while they are growing. Plant roots are very opportunistic. They'll love it. You give them food, they'll take it. But at the same time, those byproducts are being used by the other functional groups in the soil for survival. And the second group's byproducts gets fed to the third group of third group of microorganisms, right? So you see the chain of events that the microorganisms in that soil are reliant and dependent on each other to interact, right? So with these byproducts, when they are in constant production, you see a stable environment, a stable ecosystem that is in tune with the plant or the crops growing. So now let's say now you bring in a sudden stress, a heat or drought. When you have it, not all the microbes will be tolerant to the stress, to the certain heat pressure, because you don't have moisture. So you don't have moisture, so the minerals are not being solubilized. So the microbes can get it. The plants cannot get the available nutrient, but not all microbes are the same. Remember, you have thousands of species there. Some of them can withstand that heat, and they're creating their byproducts like acid, which dissolves that mineral and making that nutrient available for the plant to take up. So even though you are under stress, the show must go on, and because you have a diverse biology in your soil, it is carrying. Some of them are dead, but many of them are alive, and they are carrying on the process. So that's why functional redundancy is important. So yes, 10 of them are doing the same thing. Why should I care? It's redundant. But in nature, you see redundancy. That's where you see it. And redundancy is good in this case because environmental stress is sudden, unpredictable, and in a very high pressure growing system that we see with rising prices with the farmers, they need to rely on this redundancy. So that's not limited on only one or two species that you put. You are reliant on thousands of species. If some of them are dead, that's fine. The process will go on with the remaining one that are alive. So that's why you need redundancy in your functions.
I like it. Yeah, no, that's a perfect example. I always like to say, hey, let's look at a forest, right? It always seems to be pretty resilient, right? It's like the perfect picture of that redundancy, right?
Yes.
I use that.
It can go through droughts. Do you say the same thing, Jared?
Yeah. Yeah.
If I may say, always when I'm talking about redundancy, I always like to say what our farmers are trying to achieve is perennial function, like a forest, a grassland, in an annual system, right? That's what you get from biology, using carbon and biology in the mix. So if you want perennial functionality in an annual system, work with your biology, work with your carbon, build up the organic matter, use your biology as it requires, depending on your crop's demand. You are in for the long run because we're in that big puzzle of soil health, regenerative ag. And you just need to, as you go through, you need to piece that puzzle.
Yeah, no, absolutely. And that redundancy is important, like you said. It's because if one species falls back, there might be another species right there ready to take its place and do the same function that's needed, which is also goes back to that crop insurance, or I don't want to say crop insurance, but the insurance policy, right? It's that insurance that you're looking for.
Yes.
Perfect. And now, also these microbes. So not only do we need this functional redundancy, but then also we're going to be needing a lot of nutrient unlock from them, right? And that's what they kind of do. They cycle nutrients. There's different things. So if you can kind of explain how these microbes, Keyshawn, mine minerals and nutrition to make them plant available. And if you can, just give a brief explanation of the soil food web. I don't need the full detail, just a brief explanation of that. Yes. We could be here all day, and that's fine. Yeah. And it's funny you say that because this is the stuff that, people that really understand soil, they geek out on, I can say, right? It is the soil food web. It's the life. It's the ecosystem. But if you could do that and then explain that relationship between bacteria, fungi, and the predators that kind of release the nutrients in that system.
Excellent. Thank you. So I will start with how microbes mine the mineral. There are lots of ways bacteria and fungi mine minerals, release nutrients, and makes it plant available. The most common one is biological nitrogen fixation, right? Just rhizobia is creating an infection in the root zone of a soybean and just getting in. And then that infection is creating its own nitrogen, letting the plant create its own nitrogen. So that's one example of mining nitrogen a mineral. Others are when we talked about it a little while ago, when the microorganisms are interacting with each other, they are creating organic acids, enzymes, volatile organic compounds, they're creating chelating agents, sterophores. So I'll first start with organic acid, like citric acid or malic acid. When they're creating those acids, they're dissolving that tightly bound calcium or magnesium or the potassium that the plant need that is bound with the soil complex. That's a big slurp of organic matter, mineral, all tied together. Microbes are creating acids to dissolve it. So when they're dissolved, they're coming into soil solution. And when they're coming into soil solution, they're coming into as free ions for the plants to take up, for the other microbes and fungi to use it.
That's the bioavailability. Okay,
Yes.
perfect. Yeah.
Yes. Some of them will then be fixed with organic mineral again. But if you have biology there, that process keeps going on and on. Capture, fixing, releasing. And that's the dance that microbes play, in the soil. And fungi are very good at mining minerals because, to me, they're superheroes because they can be here, right, far, far from the root zone, but because they have hyphae, they can spread. And as they spread, they acquire or they chip away nutrients from organomineral complexes. You see the organic matter and the mineral in the soil. They create their own chelating agent and acids, and they can take that nutrient out of it and use it for their own food. And they do a very good, interesting exchange with plant roots. Plants gives them a carbon, they give them phosphorus or calcium. And other way microorganisms can mine mineral, actually not only mine mineral, but keep those available calcium, magnesium, potassium onto their sphere, is creating biofilm and EPS, extracellular polymerase, where they create around themselves. Those minerals are kind of glued to those exopolymers and in the biofilm. And then you have one bacteria, you have billions of bacteria creating that biofilm, and all the nutrients are, gooey, sloopy in that mix, and plants can take it from there. And other forms are siderophores, which is a very specialized mechanism for iron. Ferric iron is very important. It's micronutrient mining, and microbes create siderophore that can actually hang on to the iron and release it to the nutrients and to its other buddies. So
understandable. Yeah. So that's kind of the basis of it, And I'll tell you one thing, you know what? If the guy that's trying to sell you microbes can't explain that to you, I'd probably double check who's selling you microbes, right? Or who's selling you an input.
Yes.
Because that's the true intertwinings of what we're talking about here. You know, and this is why, Purple Cow Organics does stand apart from, other manufacturers out there, is because of this reason. And now also give that brief explanation of the soil food web.
Before going to the soil food web, I want to give another example of mineral mining. I think you'll love it. This is something that plants' roots and it is not biological nitrogen fixation. Lets a group of bacteria through its root to go inside and destroys that bacteria. It's like the bacteria are sacrificing themselves, entering into the root, and then the oxygen in the plant root just destroys the bacteria, part of the bacteria. It keeps however nutrient you want inside the root, and then the remaining ones are coming out. It's called rhizophagy, and it is being studied very recent time. When I say recent, in the last 10, 11, 12 years. So a certain group of microbes are going in, 10 of them are going in, 3 of them are getting dead, becoming the nutrients for the plants, and then 7 of them are coming out. And this cycle goes on and on and on. So
that's awesome.
Microbes and plants, they have that interesting relationship. And going into your next question on the soil food web. So at the crux of the food web, we have the photosynthetic organism that can use sunlight and create their own energy. You have the plant and you have the sun. The sun's energy and CO2 is creating glucose, essentially sugars, and they are getting out from the root going into the soil. So that's the first thing that you do in your food web. That's your
first trophic level, base of the food web. That's
basic.
The foundation.
That is the foundation. And a plant does not live forever. It will be dead. It will fall on the on the ground, on the soil, and those dead residue or the plant material will then be eaten by the second trophic level, where you have your bacteria, your fungi, and your root-eating nematodes. So they use that organic matter or the crop residue, and sometimes live roots when they're living it, and they also feed off of each other as well. So that's your first trophic level. And once they go through their cycle, and they are not like us, knock on wood, 90 years. They don't live like 90 years like us, but they do like 10 minutes, 30 minutes, 2 days, right?
Live fast and die young. Yep.
Yeah.
Yes, there you go. So
I like that. That's true.
they when they are dead, they are becoming nutrient. They are being acted upon or fed upon by the tertiary or third tier trophic level. You have your arthropods like millipedes, sow-bugs, termites, and then you have your fungal feeding nematodes, or a little bit of bigger nematodes, and you have the protozoa that feeds on bacteria. They don't do a lot on the fungi, but bacteria, they just engulf them, right? Because they're tiny. And while they're doing it, they're releasing nutrients and the plants are taking it. So you see, all the available nutrients, they are finding their way to the root. And if you take one of the trophic level out, right, you have a system breakdown.
Yep.
So after that,
you have a house collapse, right? Easy
Yes,
way to
you
have a house collapse. Yep. The roof falls in.
Yep. And from the third trophic level, you move on to a little bigger ones. You have your artworms, you have your bigger nematodes, you have your centipedes, caterpillars. They feed on the third trophic level, and themselves call themselves fourth trophic level. And this cycle goes on. And then at the very end in the food web, we have birds and other mammals.
Yep. Which that's the above the soil.
That's the top tier. There's the top tier of the food web. So while this whole process goes on, one thing is resoundingly common. You live, when you die, the cycle doesn't stop there. You get eaten, and that nutrients is being released, so recycled, that finds its way towards the next trophic level, or at the very end of the at the crux, the plant roots. In doing this process, minerals are getting bioavailable in ion form. Plants are taking it. Microbes and fungi are taking it. Fungi are really, really good at it because they can extend their hyphae and they don't need to be present at one spot to get food from 10 feet away. Through their extension, they can get it. So that's the food web in a nutshell. I think I was brief.
No, I like it. That's all we need. I mean, if we go too deep, some people, will lose them. So now, can you explain that relationship between the bacteria, the fungi, and the predators that do release nutrients? You kind of did in that, in the soil food web explanation. Yes. But just those simple things, bacteria, fungi, and then the predators that release the nutrients to the plants.
Okay. So again, depending on the pH, you can have a bacterial dominance. We will have fungi, more bacterial, closer to the acidic. And on the alkaline side, a little less bacteria, but fungal population established. So when you have a group of, diverse bacterial population present, they, again, through their interaction, going to create organic acid, volatile organic compounds, hydrogen ions, hydroxyl ions, and those just not stay there. They find its way because it's a very tight space, right? We're talking about 2 tiny soil minerals, and in the crack, there is a decomposing root hair or a corn stover decomposing one, and bacteria is there. It's creating its byproduct. And while they're creating the byproduct, they're further degrading it. It's not maybe a good analogy, but if you drop a little bit of acid on your skin, it's going to dissolve, right? Degrade, right?
Yeah,
so think of it that way. It is dissolving it. And while doing it, depending on what type of organic matter you have in the soil, it is going to be released at a different rate. Let's say you have very easy sugar, or you have some sort of fibrous roots. They will degrade faster. But if you have a wood chip, or a corn stover, or wheat straw, you are going to need more bacterium interaction or a fungal interaction, and that will take time. So now that goes into the discussion of does quality of carbon that you have in your soil really matters?
Yeah.
So do you want to give a sugar spike, or do you want to give it a balanced diet so that they can chip in slowly, that in that way, releasing more nutrient for their own body bacteria, for their neighbor fungi, and their and the plant's root are taking it.
Sure. And so that's kind of like what you're talking about with that plant providing that buffet for the soil food web due to the fact that, it's not a potluck where everybody brings chips, right?
No.
Okay, yeah, exactly. It's a buffet of food for them.
Buffet of food, yes. And different microbes prefer different foods. Fungi prefer a little bit of complex food because they have thicker cell wall. They're a little more developed than bacteria. Bacteria, simple foods better. So if you have a lot of sugar, cellulose, you'll see a bacterial population in your soil more. But if you throw in a complex food source, either through your plant or you added it, let's say compost or any other organic amendments, fungal will take time and they're more specialized.
Yep.
And then
they're looking for those harder food sources to break down.
Yes.
Those wood chips, those things that take a little bit more time.
Yes, they take a little more time. Again, that goes to the quality of your carbon that you have in your soil.
Sure. Absolutely. Well, no, I think that was an excellent explanation of that. I think it's going to be great for the viewers to be able to see, that explanation of the soil food web, kind of the interactions, what really happens. And not only do microbes and plants talk to microbes, which you kind of said, through exudates, and I could say that's talking to them per se, and that's really what it is. That's how the plants do talk to the microbes. It's via exudates to ask for those specific nutrients, the Uber Eats of the soil world. And you explain that. Now, can you also explain a little bit about quorum sensing? Because that's the bacteria, not only, so the plants provide the exudates, which is, like I say, the Uber Eats of the soil world, right? They're providing that food to those bacteria, but then also those bacteria are talking, correct? Or the ecosystem is talking, correct?
Yes. So I'll start with an example of stress. So let's say on a given year, you have an early drought. And when you have drought heat stress, not enough moisture. So in your root system, you don't have much moisture. So minerals are not being solubilized because you are lacking moisture. Because you're lacking moisture, you have a little bit of less biology. So in that situation, that particular plant will send out SOS, save our soul signals. And in the form of heat shock protein, the common one is AHL, and that goes through the root into its own rhizosphere, where the bacteria and fungi are dwelling, right? They are dwelling in their host rhizosphere, in the tiny cracks of the soil and around the root, plant root. They see it. All right, why all of a sudden the food quality is going down? We have been, every day there was a balanced diet. Now every day we are given porridge, right? Let's say porridge. Well, so that's just SOS. Okay, so the food quality is changed. So that means something's going on with our host. So they pick up that signal. That's the signal AHL that plant gave into the root. And then the bacteria picks up. It mostly happens with bacteria. The bacteria picks up. What they do while picking up that SOS signal, they think of themselves, okay, we need to help our buddy, our host. So we're talking about one bacteria. Let's say one. It's a tiny one. What it can do? It cannot do much. It sends out its own signal to its buddy in a certain frequency, right? Those are called autoinducers. And those chemical signals that the bacteria releases, they are very small diffusible particles. And that helps them, that individual bacteria, that signal to its buddy, because they cannot see, they cannot hear, right? But the autoinducers are being picked up by other bacteria and they group together. When they group together, they start interacting. They create an environment around the root zone that creates organic acids, that creates those and makes those unavailable P, solubilize them into plant available, phosphate or sulfate. Yep. So in that instance, a group of bacteria came together through their own signaling when they got the signal from their host plant and helped. So that grouping together is the quorum sensing. And it's a common concept in our body in virulence, but it's catching up in the below ground. And quite a bit of research has been coming out since early 2000, late 90s. And we're trying to get into it and creating particular autoinducers so that particular microorganisms or groups can group together. It's next level research. I don't know how much it will go, but that's a natural process. When you have a diverse biology in your root, this is what happens. So it is very important under stress. Again, not every year is going to be the same for you. That is why if you have those insurers, those redundancy in your system at different touch points.
That broad spectrum biology, right?
Yes, broad spectrumness of your biology. That kind of helps to ease those pressure. First, to resist. Okay, I cannot resist. I have gone through that process, that stress. Now I can resiliently come back. Spring back.
That's perfect. Yeah, no, that was a great way to explain that, and it's funny because back in 2008, when we were first coming into this, we were, some of the people we were working with, we were talking about quorum sensing. And when you take that to a producer in 2008 or a farmer, they looked at me like I was about nuts, if you really want the truth. And it was the truth, right? I mean, the research was there, but we were way ahead of, I shouldn't have been telling farmers, hey, look, man, your microbes, your soil, it's talking, the bacteria down there, when you have problems, it's talking to each other, because they thought I was nuts. But the reality is that's what happens. And that's a perfect explanation, Keyshawn, of it.
And it also happens above ground through the plant's leaves, because sometimes the plants under aphid attack sometimes, spreads pheromone. So it creates other butterflies or other, insect population to feed on it.
Sure.
So what happens above ground, it also happens down below. We just need to put a microscope and look at it.
Yeah. Yeah. And I was telling them just to imagine, right? And they were saying like, I imagine you getting off my farm right now at the time. So, but anyways, yeah, no, that's great. I appreciate that. Now these next ones, I'm going to hop into it. I appreciate that, the science side of it, of really what, the soil is. And also I want to bring up later on in this too, companies out there. And I know there's a lot that are coming out that are starting to genetically modify organisms, and we can talk about it later. And that's something that whenever we add those genetically modified organisms into soil ecosystems and soil ecology, it starts to cause some major issues. So we'll talk about that later. But Kyle, let's talk about the year one experience, buddy. All right. When a farmer switches to a biological program, whether that's your guys' program, right, which we want broad spectrum biology. Like that's the first key that we're going to look at, right? Any producer, any farmer, I don't care what you grow, even turf guys, you name it, you want broad spectrum. So say let's talk about your BioActive Liquilife or the Liquilife Plus, right?
Yeah.
What are we going to see first? Is it root mass increases, water infiltration, bricks increases, fertilizer reductions? Like, what do we see when we start to integrate these broad spectrum biologicals into systems?
Sure, Brandon. First, I would start with how we are making an introduction to their system. Is it a residue pass for residue digestion? Are we coming in with a starter? Are we coming in mid-season with nutrient application and a biological and a carbon source? Oftentimes, I find it the easiest and the most visual with a new grower to come in with starter. Move those high salt index starters as far away from the seed as we can, and come in with a carbon source and Liquilife in furrow or as close to the seed as we possibly can. And I have many pictures of side-by-sides in soybeans, corn, wheat, cotton. We have a robust root system. We have that dirt dreadlock hanging on the root system and development of that below ground community, and it's visual most of the time. That doesn't always translate into, if it's just that application, into significantly more yield. But if there are stresses, you set that seedling up for resilience throughout the season, whether it's drought or wet stress. You just provide a community of support around that seedling plant. So ideally, that's what I would like to look at. The second most common as a new introduction for a customer or a grower that's wanting to work with biology would be like a mid-season application, probably nitrogen. And so we look at a reduction usually in the mineral nitrogen. Most oftentimes in the Midwest anyway, it's UAN. It's 28 or 32% nitrogen.
Gotcha. Yeah.
So we take 10 to 20% reduction in the volume of that and replace it with a carbon source and Liquilife or Liquilife Plus.
Yeah, no, absolutely.
We're providing a buffer with that fertilizer with the carbon, and then offering a community to help metabolize that and stabilize it for the plant.
Yes, kind of to our points we were talking about before in the sales process is most farms, if Kyle, Kashan are on them, aren't going to necessarily trust us to do, 10, 20, 30% reduction on all their acres, right? So it is a process of, a lot of times, they're setting up multiple things to say, you can trust it. It's going to work. You're not going to lose your livelihood, because it's a risk. And I do respect that a lot from farms, that just to jump into the pool without seeing it yourself, I mean, they could lose their farm, right? So they're serious decisions.
Absolutely. Yeah, no. And I would have never thought I would have heard Kyle talk about dreadlocks on roots, but hey, buddy, you know what? That's great.
I don't know the technical term. Kashan, I'm going to punt that to you.
No. It's true. Like that's what it does look like, right? Whenever you start seeing, those roots start holding on to more soil, it's soil aggregation, those types of things. So no, I love that. So you're going to see some reduction in fertilizers. We're going to see some better root masses, potentially water infiltration, depending on crop, increased bricks. And really that's all leading back to, I think, better nutrient uptake, that buffet to a plant versus just P and K. What happens is over time, the system breaks, the plants become unhealthy, the soil becomes unhealthy. Bacteria want a good buffet just like, we do. And so I think that's what you're going to notice. So that's perfect.
Yeah, we may see like mid-season as well. If you do some tissue or sap analysis throughout the season, you might see an elevated level or slight increase in those micronutrients in particular.
Sure, yeah, they're being uptaken, and that's probably some of those root exudates that those plants are pushing out to the bacteria, saying, "Hey, that's what it is. Hey, we need some of this micronutrient, and now we can uptake it. We have the proper bacterial communities there, or microbial communities, whatever that looks like, in order to cycle it and make it available to the plant then." And then we kind of talk a little bit about like what you'd feed those microbes as well, right? Discussion on the microbial foods. And there's a lot of talk, there's some people that, like Keyshawn even mentioned, there's some simple sugars, like people will say, oh, just throw molasses out, you'll be fine. There's a lot of people that are against it because, yes, you get a massive increase in biology, but then you get also a massive decrease in biology. Only feed fish fertilizers or only give them, humic acid or whatever. So what food sources do you like to see microbes consume? I guess you could say like the lunchbox for the microbes. What would you guys say that is?
I'm going to say oftentimes if they're not currently, let's just say we're in that scenario again with the new to me grower. It's the first year or season that I'm working with this grower. I'd look at if they're currently using one, try to utilize that rather than change too many things in year one. And if they're not, try to recommend something that they can cost effectively get to the farm. So not looking at perfection necessarily, but very practically, is this a molasses market? Is this a market where we can cost effectively get fulvic acid to, depending on what that is. I know Kashan can help me out here on the rate of digestion of those carbon sources and which microorganisms have a affinity for each different type.
Sure, yeah, and microalgae is starting to become a big deal as well, right? By really multiplying. It's a great carbon source. It's great for indigenous microorganisms and for products like your guys' broad spectrum microbials. It's starting to become a really big food source for them. So
kelp's another good one too. So we actually, I don't know how familiar you are with it, but I did some R&D. One of our challenges is we need to provide a food source because our product is dormant, right? That's one of the things that makes it different is it's dormant until it gets a food source. Okay. Well, there's a lot of different food sources out there as we're talking about, but we were like, okay, well, we need to at least have a solution internally that if somebody wants one, we're able to do it. And, it's called liquid supercharger and it has a variety of different food sources. So it has a small amount of sugar, 3, different types of sugar in it, not molasses based and inverted organic sugar, soy protein hydrolysate, and then fulvic humics. And then kelp's another important one where you're giving it a lot of different food sources, but this product, it gets expensive, right? So, how can you, so it goes in with Liquilife at a really low rate, like an ounce a gallon. And that's just to wake everything up. And then to, Kyle's point is then what else are they using? Do they have enough food? Who are their vendors? All those different types of things that go into those conversations.
Yeah.
But yeah, it's always a challenge. And Kashan again can get into kind of, what eats what. That's why we love having him around. We always get to learn something too.
We have kelp as well. Like we use kelp, we use soluble kelps, all different types. It just depends on really where that farm's at, what's available in the area, because you and I know shipping stuff and the logistics of things are tough. We are finding also, though, there's some kelps that are high in salt. So we have to, we're watching out for that, right? And when you're saying an ounce, you're adding an ounce per gallon or something like that. It's very little. When people are utilizing kelp the way they where a lot of manufacturers of kelp or harvesters of kelp are saying to utilize the product. In some high salt soils we have seen, it's like, well, what kind of kelp do you have? How much salt's in it? Those types of things, so something that we always look at. But yeah, no, Keyshawn, if you would also, I love it. So what do you think about the lunchbox?
Okay, so when I think about that lunchbox, I want to think about what do you have in your soil? what population. Let's look at your bacteria to fungal ratio. Who do you have most? Let's for an example. Well, many a time farmers use compost, right? It's an organic amendment. It's good. Our company sells compost. Over repeated application for numerous years, let's say mono application of compost for let's say 10 years, it's going to drive your pH up, right?
Yep. It
so
will.
Now, higher pH, different microbial population, you're going to see more, a bacterial one, right? But then you want the fungal ones who are long living, long lasting ones, right? So if you feed quick sugar molasses, okay, bacteria is going to come and eat it. Nothing left for the fungi. So you got to,
Sure.
during the process, you need to tweak your carbon source, tweak your food source. Same goes the fish hydrolase is very acidic. If you keep on adding, it's going to drive down the pH a little bit. A lot of fungi, not a lot of bacteria. Maybe you planted it, your seed needs fast plant availability on temperature around the seed for germination. And if you feed something very, some sort of humic acid, bacteria cannot get it. Fungi takes time. So you want, okay, quick sugar here is good. So again, it's depend on who you have and what are they preferring at that time. So again, you can to a certain degree control what you are doing. And in that food, microbial foodscapes, sugars, crude protein, those are, and cellulose, hemicellulose are quick to go down. As you move into more fulvic, humic, and lignin and algae, those, they are tough to break. When I say tough to break, that means they take time to break. I've seen with molasses in a jar test, looking at CO2 respiration for the microbial, exhaling. Some of them will, okay, after 2 days, tip. But some of the molasses will go for 2 weeks and then plateaus. Algal, kelp, you have that respiration, not big jump, slow, like one stair at a time, the CO2 respiration. That means you're feeding biology. Yes. Some of them in that mix will be better feeder than other, but you are sustaining the population for longer. And
which is
while
important.
you are doing, which is important, yeah. Especially if you have a diverse one, right? Diverse biology. And in nature, in soil, you see that, right? A diverse biology.
They're not. And that's just us. I mean, some people, they're huge on molasses and, and that, like you said, you might need that extra spike, whatever. Personally, we don't ever really recommend it as much. That's just our personal take on it, just due to the fact that we don't want to see those massive spikes and then massive fall offs. Like we want to provide a more nutritious food source, something that's a little bit harder to, break down. It's going to last. That respiration or that curve is going to be a lot longer to try to really feed those microbes, grow big populations before they do start to dip.
The other thing too that, we didn't even really address yet is, besides adding things to the soil, keeping things on your soil is probably the best food source, right? You got the no-till, you got breaking down crop residue, regenerative ag, so cover cropping, right? So all those things those are probably the best scenario.
Absolutely, because those plants, right, the cover crops are giving the exact exudates that those microbes need. Not only that, but it's giving it structure and a home, right, exactly, for them to go and live and want to thrive. And that's a great point, Jared. It really is. That's and it's important. And in those regenerative systems, having cattle, and there's all of these aspects to it. So I think that's great. I think we got down to the bottom of that lunchbox, pretty good. Now and this is the last one. It's always, I think you can say, the kind of addressing the elephant in the room is, does biology clog the sprayers, Kyle? Like, does it clog sprayers? What's your practical take on, the utilization of it in boom sprayers, injection systems, drip irrigation, and then other common application methods? If you could kind of just talk a little bit about utilizing biology and kind of application systems.
I'll start out and say it can plug some systems, but usually working with a new grower, like Jared said before, when you're dealing with single strain or simple mixes of bacterial biological products, their past experiences is their basis of their knowledge. And I run across quite a few farms that have had issues with having growth in the spray mix. That's where most of my practical application is in spraying and planting units. But when I look at it, there's a few kind of guidelines that I look at, and that's one is screen size. 50 mesh is great. We don't need to probably go down to a 30, 20, or 16, but try to stay away from 80 100, 120 mesh screens for our systems. Sure. That way we have a little bit more course. We're still protecting ourselves from, some foreign objects in the tank or in the system, but allowing that if we do get some growth with our tank mix, if I'm looking at a kind of a new cocktail or something that the grower's using, jar test it.
Yeah,
jar test it and see, do you have 36 hours to use this? Do you have 48 hours to use this? And just kind of monitoring that and monitoring it for growth to see if you need to either tweak your recipe before the season or, look at what your timeline is on before you're seeing a lot of growth.
Yeah.
It depends on dilution. So if you're only using a gallon or two of a biological and a gallon or two of a food source, and then you're using a lot of water, let's say you're using 18 gallons of water, 16 gallons of water, you're going to raise that pH closer to neutral and you're going to get a lot more growth. So if your total tank mix or where you're storing it mixed is more acidic, you're generally going to have a little bit more stability until it comes time to awaken those microbes and go to town and get them sprayed in the soil or on the plant.
Yeah, you want those cells to be able to get through the screen and then get out onto the field. A little bit different nozzle size, right? Maybe a little bit bigger droplet size on nozzles if we're talking boom equipment or spray equipment. Same principle, I would take it in injection systems, right? If we're working in greenhouses and things like that, we don't necessarily want the finest mesh filter there is, which is tough because some people freak out about clogging drip systems, right? But the reality is you also usually have end of line clean outs. So like clean the line out, right? And a lot of times what we've noticed even is sometimes they will create those biofilms and actually clean up calcium deposits on emitters, those types of things. So you probably recognize that as well, Jared, when you're working in greenhouses.
And we do have, we spec basically 20 mesh, right? So we've done a lot of work over the years when we first started making this product where, we kept working on what is the appropriate size. And what's interesting about Liquilife, even if we go back to the lunchbox, is there is some physical particles in it, right? Now, those are good, right? Those add an additional food source and also have their own living communities. So, when we were going back and forth, it's like, well, we can take everything out, right? But is that going to be the best result for the farm? And yes, it takes a little adjusting because it's not, there is some particulates in it, but if there's no particulates in it and the farm's not going to get the result, does that make sense? So, those are some of the challenges. And I'll say, 10 years ago or so is when, all that work kind of started. There was, complaints, right? That, and that's when we kept getting to work on it and we came up with a spec. This is what we recommend. Now there's greenhouses and other people that get it through much smaller than 20 mesh, but obviously we want to, and they do testing and all that, but we want to make sure that we can give the most accurate representation that we can. And they're diluting it and all those other things too. So it's also not a perfect science. And to the point of stability testing, Kashan's a great asset for that. When I used to do bench testing, it's not as thorough as what Kashan's been doing. So we actually work with, dealers and farms and, we have a person on staff now that can do that really scientifically and kind of say, I wouldn't put this in a tank together for very long.
Sure.
Or this should stay stable.
Yeah, it's those jar tests. And that's one thing, Kyle, that's a simple in-field test you can do, and it's going to tell you a lot real fast, right? Yeah. If it gels up in a jar that's this big, it's a lot better than cleaning out a 100-gallon tank. And really, you get the call first, then they clean the tank out. You know what I mean? It's like, that's usually, what happens. I'll share some of the jar testing that he's doing now. Like, I think you'll be shocked at the methods that Kashan's using because it's not as, again, the typical jar testing that I was doing was very similar. What do I see? Does it blow up a balloon where he's measuring pH at different times and all sorts of different variables? And is it reacting? And even if you can't see it visually, is it changing? And his first report he sent halfway through the mid-test on some of these jar tests that we're doing on a larger scale is remarkable work. That's awesome. That is awesome. And that's the stuff that's missing right now from a lot of different manufacturers out there. They don't have that data. they say, oh yeah, just mix it with this or mix it with that. They don't have that hard data. And that's great that you're doing that, because that's only going to be an added benefit to the end users of your guys' product. Yeah, no, I think that's perfect. I think that, oh, go ahead, Kyle. I'm sorry.
I was going to say, to the two other practical tips that I talk about, since we talked about tanks and residues, is if that tank has been used to store particularly nitrogen or some other fertilizer source, clean it out first, thoroughly, chemically, because you can get salt deposits, especially in the bottom of that tank. When you add Liquilife or you add a carbon source into that in particular, some of the carbon sources are pretty acidic. They will clean that tank very well, and then you will not be very happy with all the salt that you just freed up from the tank. And then put on your fields, or worst case, next to your seed with the planter.
Yeah, there you have it. And you're wondering why stuff's not germinating.
Yes. The other one is, most of the time in the agricultural setting, we're getting well water or ditch water for our water source, but we do have a substantial amount of folks, particularly in the lower Midwest, that are on rural water, which is chlorinated.
Yep.
So we want to make sure that we pump that ahead of time for our mix water and leave the lid on so that chlorine can gas off, or use a dechlorinator before we add that to our tank mix.
Gotcha. Yeah, no, I like that. Yeah. And that's the same thing we do. People don't realize that chlorinated water kills bacteria. They don't think that, that chlorine's put in there so that the water is nice and pure, right? But it kills all bacteria. It doesn't matter what it is. So what we've always found is like fungicides, those types of things, we never mix with that stuff, because it kills everything. It kills funguses, bacteria. I mean, that's the one that just pretty much nukes everything, and you end up with nothing, right? Just an expensive bill in the mail and no life in your soil.
Interesting. So, as there's stories on our website, et cetera, about, people that have cut those back. But obviously, even the people that don't use any fungicide, if they do have an immediate need, they might need to use it, right?
Sure.
To save their crop. Well, we typically recommend, use Liquilife then, 2 weeks after, right?
Absolutely.
Well, they've been getting way better results. We can get that population back up in hopefully a reasonable time where you had to deal with an emergency need. And you're not going to ever be able to probably cut all fun. And we don't recommend that. You know what I mean? We let the growers decide those types of things. And we have farms that have been using it 5-6 years who have to spot treat occasionally, but otherwise, can manage. The other interesting thing where, if you start looking at organic farms and fungicides and pesticides, is there have been customers that have mixed Liquilife in some of those, think neem oils, the Sinatrons, those types of things, and have seen a better result.
Sure.
Which is interesting because, I don't think it's killing everything, obviously, or is the broad spectrum nature of it also acting as a food source for some of those bacteria species that survive? And
that's what I think it is. It's probably food, right? I mean, there's a certain community in there that's like, oh man, this is actually the food I was looking for. Thanks. This is the, and it works better. And that's funny you say that regarding the fungicides and things, because, a lot of the microbials that are out on the market today, they're in bacterial consortiums that people are selling. They're not FIFRA registered. So you can't use them in lieu or make pesticidal or fungicidal claims on them. And it's a big deal. But the reality is we do have some producers that, they just have chosen to utilize microbials or broad spectrum bacteria in lieu of some of their fungicides, just to try to build plant health as much as they can. And I don't want to say in lieu of, they're spraying it out just like they would their fungicide, but they're just trying to build life. Like they finally switched that mindset and they're like, wait, I don't necessarily want to kill anything. But if they do have to use a fungicide, we do it. There's a lot of producers that are starting to do it in onion crops we're seeing where they were, they had all kinds of issues. And now they're just trying to build that really like as healthy of a crop as possible. But if they do run into the issue, the fungicide comes on. And then exactly the same thing. We recommend the same thing a few weeks after that's put out, because basically what you've done is you've kind of created an open petri dish, right? Like that's the way I explain it. Mm-hmm. Anything that lands on there could be opportunistic, right? It can grow, it can start to take over and do those things. So that's cool that you guys are doing that same thing.
And one of the funnest parts of my job is I handle all of our registrations, and it's a lot of fun. And it's interesting on some of the, rules they have. And typically what we do is tell farm stories, right? We know, the big guys that are going to come target us if we say, it's going to, eventually make it so you don't have to use that many fungicides, right?
Yeah.
And so we tell stories, and we talk more about competitive exclusion, similar to what you did. So if there's a lot of good guys there, well, it's going to be harder for the bad guys to take over.
Absolutely.
And that's pretty much, the value proposition that we push, but try to stay away from the claims because again, that's a big market, a few really large players, and a lot of them, they put a lot of money in to make sure
they're waiting.
Yes.
And that's the same thing. That's the same way we explain it. It's Gauss's law of competitive exclusion, right? Like that's what that is, so that's perfect. Yeah, we'll hop off that. I'll leave this one. We're going to kind of start wrapping up now, but I know you guys are on for a while, but I think this is great information to get out to people. This is the stuff that people have to hear, producers, but this is kind of the golden nugget round, I like to call it. If you had to start a dead soil, and anybody can take it, it's up to you, or you can all put in your own piece on it, whatever you'd like to do. But if you had to start a dead soil from scratch with only one biological practice, what would it be? Would it be the integration?
Let go first.
Okay, yeah. Would it be the integration of biology? Would it just be feeding what's there, the indigenous microorganisms? I think a lot of times it depends on the system, but yeah, go for it. If you want to start out, Keyshawn, go for it.
Yeah, so I would go with residue management because in your residue, you already paid for the seed, you already paid for your in-season cost. Your corn or wheat residue has carbon, has nitrogen, has phosphorus, has potassium, a little bit of sulfur, and some other trace elements. And they're just lying on top. If you manage that with, with biology,
yeah,
let the biology work on it.
Putting liquid life out over the top of it.
You can use a broad spectrum liquid life on top of it, and that initiates the process of breaking down that tough lignin, cellulose, hemicellulose mix. Because you have fungi, work on lignin, you have bacteria, it will work on cellulose, hemicellulose, and the easier parts. Then you are essentially releasing those nutrients, banking them in the soil as a soil nutrient bank, your very low APR savings account. When you go into next season, spring, when everything is happy and, sunny, there you go. You have nutrients in the soil that you already paid for last fall.
Man, I like it.
And plants can take it. So I love residue management. I love to see how residue works.
Very similar to a forest again, right? All of that stuff falls down, and guess what? It gets recycled, and it just goes right back into the soil to provide the fertilizer, whatever's needed for that next year's forest.
Perennial functionality, how can we fit that in an annual system?
I love it. That's great. Yep. Anybody else? You want to add anything, Kyle or Jared, on that?
Sure. I'll just say what came to my mind, or mine would be a reduction in high salt index fertilizers, particularly applied with the planter and overall for the system.
I like it. Yeah. Reduction. Get salts away from the seeds, right?
Yes.
Get salts away from those plants trying to germinate. All we're doing is when we feed them salt, it's kind of what happens to me when I eat too much salt, I get dehydrated. Mm-hmm. My lips hurt. It's not good, right? Same thing to the plants. It's the easiest way.
And oftentimes in high salt soils, we see potassium deficiency. So there's interactions throughout that whole system, and that gets wreaked havoc with that high index fertilizer.
Sure. pH issues right there. That's what I'm guessing. But Jared, anything you want to add to that?
I generally agree with both of them. Again, most of my stuff probably, there's unrealistic options, right?
Sure.
That wouldn't work. So, again, compost is always going to be great too, but you're not going to go start a 1,000-acre farm and put 6 inches of compost and till it in your farm.
Yeah, we'd all like to, but then you would probably own the farm or something like that.
Exactly. So that's where my mind goes. I'm like, well, that's not feasible. That's why we developed what we did, right? So
that's perfect, man. I like it. Yeah, no, I think that's great. And that's right. Build that structure, right? Even structure can be built somewhat from that crop residue being recycled back into the soil, getting rid of those salts, mitigating that, the compost or whatever that structure looks like. If you can get that structure built, then we put the life in, right? Give it some energy, some food, and then track it, right? And keep doing that same thing until we build soil. You guys excited about for this upcoming year at Purple Cow Organics?
I'm excited primarily to see what this team can do. As we kind of talked about before the podcast, Brandon, one of the most difficult things of my job I've found is finding like-minded people that believe in biology, are getting outside of big corporate ag, single species, NPK, not needing to, sell 60 things out of a book to a farm, and be willing to go out and educate and realize that sales process is going to be slower. It's going to be educating, similar to this, but it's worth it. And they have passion to do it, because if they don't have passion and don't believe in what they're doing, they're not going to stick around long. And then from there, they have to go out and find dealers or distributors that also think like-minded, like yourself, right? And there's not a lot of those. I mean, there's more and more. And I think really what's happening is a lot of the dealers are like, well, we can differentiate ourselves from some of the major co-ops by showing them a better solution. But then you get into geography, right? Well, if their co-op is 500 miles closer, and they're getting 10 things they need from them, how does that work? So,
Yeah.
And the only way it's going to change is by educating the farms, and they're going to need to eventually start asking those questions and demanding a different product set. And, again, that's what I'm excited about. We got Kyle and Kashan here. I'm super pumped about it. I tell them that every day, and I'm excited to see what they can do. And I think that they'll keep building a good team.
I know they will. I look at it and you've put together something, in those guys, and not only that, but yourself, but a good group of people. And that's what, when you said that about education, hopefully we can do more and more of this kind of stuff with you guys as well, educating people, really getting out there what's important. So if you guys want to add to that, Kyle, Kishan, either one of you, what are you guys kind of excited about? That'd be great. And then we got a couple more talking points and we'll let you guys get going, man.
Kashan's always excited. This is going to be another 20 minutes. He's right.
No, I love it. I love it.
No, I am really excited about our very, Jared mentioned, our very recent stability test that we're doing. It's something that is giving us good data, tangible data, and we just need to communicate it now. And then I am excited for the next 2 months and going into the full year, going on to traveling different parts of the country, putting faces on from Zoom to in in person.
I like it. Yeah.
And talking to meeting and talking with new folks, new people, and learning about other companies and what they do in our scape, in our agriculture scape, what they do. And this will be my full circle 1 year. So I think going into next year, I'm very, very hopeful because the way we are going toward is very positive. I love that we are talking based on data, based on numbers don't lie. So we're talking based on numbers, data, research, and going into next year, we are doing quite a bit of trials. And I'm really excited to see this year in October when I have all the trial results out and look them and try to paint a picture. I'm really excited about that.
No,
Yes.
I like it. Yeah, you're right. Numbers don't lie. And so once you get the numbers and those aren't lying, there's no, what are you going to argue about at that point, right? Other than presenting them to producers and saying, hey, guys, this is why you need to change. So that's great. And Kyle, for you?
For me, I just joined the organization here around the 1st of November. So this is my first season. And what I'm most looking forward to is getting to see all the different crops that we work with and all the people that grow them. I think that's going to be fascinating to getting to know our distribution network, getting out to see people and look at the diversity. It's not just corn and beans like where I'm from in Iowa primarily. We're looking at everything. We're looking at potatoes and sugar cane and all kinds of different crops. And that's just fascinating. So super excited.
I like it.
Year.
Yeah. If it grows in soil, it can be used, right? And not only in soil, I'm sure there's other applications as well. Cocoa. We can get into greenhouses, all types of stuff. That's great. Yeah. And I think what you guys have put together is great. A couple quick talking points. I know these are a few things that Keyshawn had mentioned. Quick, rapid fire. How soil pH controls the release of soil nutrients. We did talk about that a little bit, but I think that is a very important part that as we wrap this up, year end, these are the things and kind of forefront things that people really need to think about. How does that soil pH, how does it control the release of nutrients?
So at the end of the season, or right before you start your season, look at two things. It will be for any grower or producer. My message would be take soil test, look at two things. What's the soil pH and what's the organic matter? Organic matter will tell you how much food you need. Soil pH will tell you for whom, right? For mostly whom. So in acid soil, you're going to see aluminum, iron populating and fixing your nutrients in the organic and mineral complex. And alkaline soil, calcium, magnesium does. So if you know what is your soil pH, then you would know what element is in most abundant. If soil pH acidic, man, I might have iron, aluminum problem. So I gotta think about that. Irrigation water I'm using. If I'm using an irrigation water that brings in a lot of iron, no, I gotta stay clear. Put a filter there. So depending on what soil pH you have, different elements, different minerals would be abundant. for your plants to take up, and certain minerals would be potentially a problem that you can tell in advance.
Perfect. Next one, how different microbial groups react to soil pH.
Anytime pH shifts in your soil from acidic to neutral to alkaline, or from alkaline to neutral to acidic, bacteria will be more prone to those changes. Like as soon as it gets favorable, it's going to blow up in number, but as soon as it's adverse, it's going to die down fast. But on fungal front, they're a little more developed, thicker cell wall, more hyphae, and more like bigger. So they will react to less drastically to pH changes.
All right. No, that's perfect. And then the last one, functional enrichment, limited species versus functional redundancy, multi-species. We already talked about this, but again, it's so important to have redundancy in the soil. It's that insurance policy that everybody needs. And I think that's one of the main things, especially that Purple Cow Organics BioActive Liquilife Plus does, is that it adds or helps the functional redundancy of soil.
Yes.
Which again, we can't, you can't stress it enough, correct?
Yes. I can, you need redundancy again. You can have functional enrichment. What I mean by it, 5 different types of Pseudomonas or Bacillus species. Keep on applying them over and over. But your soil is dynamic. It changes with season, with moisture, with temperature.
Soil ecology, right?
Soil ecology. Those 5 species are not going to react similarly to different changing temperature, moisture, or soil conditions. If you are doing agriculture in a vacuum, go ahead and do it. All good. If you can do it in a petri dish, go ahead. But in soil, in nature, you need redundancy so that you have diversity and abundance.
I like it. That's where we're placing the cannons and the turrets and all of those different things, right? The snipers, the guys with the pistols, the guys with you're right. I mean, at the end of the day, awesome. No, and then just the last but least, and I don't know if you guys have seen it much, genetically modified products. We're starting to see them come onto the marketplace. And I'm not going to mention any companies that are doing it or anything like that. But what we're finding a lot of is those genetically modified organisms. They go back to that same conventional agriculture model, right? I'm going to sell them to you this year. At the end of the year, they're not going to survive. And they know that. It's kind of built that way, right? For profit. And then I'm going to sell them to you again next year to hopefully fix nitrogen and do these other things, right? How do you guys feel about that? Are you guys seeing that same thing right now, with products coming onto the marketplace?
I haven't seen a ton of those. However, with that being said, I haven't necessarily spent the time to figure out exactly how they're making the species and all that, right? But as it relates to larger players, single species, I've seen that a lot. And again, that's what makes Liquilife different. And we're always going to be running into competitors as the market grows. People are going to try to get into it. And really what it does is it makes our job harder, because if they have a bad experience, then we have to explain, not all products are the same, go through that. But it makes it harder. And people also sell programs where they'll get, this rebate or that rebate, and a lot of different things.
Sure. Perfect. Keyshawn, you want to add to it? Are you good?
I think adding to Jared's point, yes, again, that functional enrichment comes in, like 2 species that comes in coexistence with the plant, that it dwells in the plant for corn in its aerial root, and then going to fix the nitrogen. But at the end of the year, you cannot make a claim to that. You have to build another strain. So again, going back to that, again, functional enrichment, 1 or 2 species reliance. So it has to be very specialized, and a plant, there is called, in ecology, there is a term called carrying capacity. You can only do good so much. Your system has to be bigger, or, to take it up to a certain point. Adding a lot doesn't mean that you are doing anything good. Then it becomes a problem, right? So that's what I see it, like trying to make it more efficient, and where does it end?
And a quick note on that too, Brand, that I explained to a lot of people when we're talking about, the abundancy, is you can read a lot of different things, right? And they'll say scientists only know, what 1% of soil biology does or less, similar to what you're seeing with gut biology. So from my standpoint, when I look at that, I'm saying if we only know what 1% or less does, what makes me think that I know that it only needs these few strands of biology? It just doesn't make logical sense, right? So that's why it's all right. Well, here, have a whole ecosystem.
Yeah, take the shotgun approach, right? That's the thing. Well, I really appreciate you guys. We're looking forward to working with you guys further into the future. We're looking forward to, having you guys on again, talking more about, getting down into the dirt of soil biology, you could say, right? Or into the soil of soil biology. I mean, you don't want to call it dirt, right? Once it's healthy, it's soil. It's not dirt anymore. But we want to get down, and having you guys on was definitely a pleasure. This is exactly what we're about. It's interesting. Both of our companies were founded in 2000, and we've been doing this a long time, and we've seen a lot of people come. We've seen a lot of people go. And I think you guys have put together a great team there at Purple Cow Organics. I'm excited to see what you guys can do this year with your products, and how you're going to help farmers, above all, become more profitable, cut inputs. That'll make them more profitable, grow healthier crops. And not only that, but rebuild soil, right? That resiliency in soil and crops and cropping systems. So definitely, I appreciate you guys being on, for taking the time to be with us today. If you want to, where can they find you guys? What's the easiest way to find you?
Probably bioactiveag.com.
Okay.
Again, going back to, they can also find us on purplecoworganics.com, but that gets into all the other market segments. So
yeah,
again, as we grow and try to message to the right audiences, we're really leaning into BioActive and bioactiveag.com.
BioActiveAg.com. I appreciate it. Thank you guys all again for being on. To all of our listeners, if you guys would follow our channel on YouTube, definitely take a look at Soil Talks. We're going to be bringing industry leaders on. These guys are industry leaders. We're only going to go to the best of the best, and you're going to hear it, and you're going to hear the truth. So we definitely appreciate it again. Thank you guys, and you guys have a great day.
Thanks for having us.
Thank you for having us, Brandon. Thank you.
Absolutely. Thank you guys.